Today we're going to talk about the Big Tree Tech SKR version 3. Now this board recently just came out, so I'm going to cover a lot of the things that I've learned from past boards as well as present, so that you can be aware of things that may change. So the first thing I'm going to do is I'm actually going to go around the board and explain what each component is. So as you can see right here, we have what's known as the bed terminal for power. Then we have the board power right here for DC in. Then over here we have our hot end power for our first hot end, which is HE0. Then we have HE1, which is our second hot end. Then we have fan 0, 1, and 2. Now up above, what we have are our steppers. So as you can see, there's jumpers in here right at the moment. These are the default configuration that the board comes with. So technically this would be our X stepper right here, our Y stepper, our Z, and there's two ports for the Z. So you have your ZA for your motor, then you have your ZB for your motor. Then we have our first extruder and our second extruder. Then up here we have our EXP2 and our EXP1. Then over here we have our X minimum for our end stop, our Y minimum, and then our Z minimum for our end stops. Then these are used for power detect and for filament run out, but you can also use them for X max, Y max, and Z max if you so choose. But that involves manipulation of either the configuration file in Marlin or the pins file. And I'll hopefully go over that in a second. Down here we have our BL Touch terminal. So we have our servo connection here, and then we have our detection used for the actual end stop, which is possibly the same pin, but we'll check in a moment. And I'll show you how to do that. Then over here we have our LED connection. And then down in here we have our thermistors. These are used to tell temperature for the hot ends and the heat bed, which would be here in these terminals as well. So we can tell what temperature is actually occurring. Then over here we have our TFT connector. That's for our display. So if you have a touchscreen display by BTT or Big Tree Tech, you can use that. Over here we have our CAN bus connection right here. Now I'm not going to go too much into these at the moment, but we also have a couple other pins in here that are relevant. We have our PS on pin, and then the other pins I'm not super sure of at the moment, but I'll become educated on those. And then we have our SWD pins. These are used for the factory in general. Then we have obviously our fuses. So if these blow, this will protect the board in theory. And then we have some interesting things with the fan. You can now use a separate power source by moving this jumper, but for the moment I'm only going to cover the regular board power before moving the jumper. Over in here we have our USB jumper, which comes off the board now. It doesn't come with the board already installed, so you're gonna have to install that if you wish to use it. And a quick note, when using TMC type steppers, you're gonna have to leave off the actual jumper when running it off direct power, otherwise they reset. So that can cause issues. Over in here you can see that there's a boot button that you can use, as well as a reset button. I actually never use these. I just disconnect the actual cabling from the USB. or I run it off direct power to actually load the firmware on our SD drive or micro SD here. Then over here we have the capability to add Wi-Fi with these 2 ports. And we have our MCU. The MCU is the actual processor for the board. And this is where I need to go into some detail. So what I'm going to do is I'm actually going to zoom in for a second. And I'm going to point out what we see here. As you can see, it says STM32H743. Now, these are subject to change on occasion. Apparently, with the chip shortage, what can happen is this could be replaced with a different one. So if that does occur, you're going to have to change your actual settings in the Marlin firmware. But it's good to know what that is so that we can locate it later. So what I'm going to do now is take you over to the desktop so you can see what I'm seeing. So the first thing I want to show you is the actual Big Tree Tech GitHub page up here. And to find your actual board, in this case the SKR3, you would type SKR in the search window for Find Repository. And it'll bring it up right here, and then you can click on it. Inside here you can see that there's 3D printer files apparently. There's firmware. So they have a bug fix version, and the X is their version. Currently on Marlin's website, it does not exist as something you can work with as of yet. Possibly by the time I release this, it will be available, but I'll show you the actual configuration using it. But you can easily download it right here by actually going back over here and downloading the code by clicking here and downloading a zip. But normally what you'll do is you'll go over to the Marlin page, you'll go to downloads, and as you can see here, the current release is 2.0.9.3. And the zip file is right here that you would download. But we can't currently do that, and it also does not exist in BugFix. And just a word on BugFix so that you know. Inside the BugFix file, this is a development branch. That means that it's under development and it's highly unstable. Usually a release will be stable, but you can also find release notes over here that talk about what's in the last build, what they fixed, and things of that nature. Now, if we go back over here, if you run into a bug that you think you have, you can actually search on an open bug like TMC2209, and you can see if it's open by hitting enter. Now, in this case, they talk about a couple of things that may be occurring, and they can actually tell you when they occurred, so you can follow the issues here as well. But we're going to avoid that for now. And finally, there is default configurations, which I don't like to talk about because I like to show you how to configure it. But if you click over here, you can actually download the code for the default configurations. So there's example files over here. And as you can see, if you go to the Big Tree Tech one, you can see what boards they currently have. Now, obviously, this board currently doesn't exist, so you can't do much with it. But what we can do is we can click on the Marlin link over here, and we can check to see if our configuration exists. And for example, what I'm going to do is go to the Marlin folder, then the source folder, then the core folder, then boards.h, and I can check inside here to see if our board exists, which it probably will not at the moment. But if you get down here, you'll see that there's an actual core file for the for the ARM processor. And as you can see, it's not in here at the moment. There is something similar, but it's not the same board. So I'm actually going to be using, like I said a moment ago, the actual one that's up here. so that you can see how to load it for the moment. So what we're going to do is we're going to go over to VS Code. In VS Code, what you need to know is that you're going to need to download it if you don't already have it installed. And I'll leave a link in the upper right hand corner on how to install it. And I'll actually probably show you in that actual video how to actually build. So once we're done with that, for the actual download, which you would click here and it would actually populate down here. This is actually going to be in our downloads folder, but let me show you how this works real quick. You're going to right click and then you're going to extract it with this. So currently we're not going to use it because it's already extracted, but I'm going to use this one that I created from the actual Big Tree Tech website. So I'm going to go over to here. I'm going to click on the File Explorer, then the Open. And if File Explorer and all these things don't show up, like this little alien sign, that means you don't have Platform IO installed on your extensions. And the way that you would do that, I'll show you real quick, is you would, let me cancel out of here. You'll click here, then you'll type Platform IO, and it's going to be this one right here. If that's not installed, it will not work. So let's go back over here and pull out the file that we wanted to pull in. So I'm going to go over to Downloads. I'm going to click on the default Marlin that I created. This is from the actual Big Tree Tech website. I'm going to navigate to the Marlin bug fix folder. And if you don't already know this, there'll be 2 of these that you have to navigate down through when the Marlin build actually becomes available. It'll probably be 2.0.9.4. So I'm going to click Select Folder. And inside here, it'll load our environment. Now, it will look slightly different when we build. And what I'm trying to say is that the actual build that I'm going to use here will have issues, but they're actually warnings. So I'll click on the clean and you'll see. So all these yellow things right here are warnings. These possibly will not exist when Marlin's firmware comes out, but you may see them when you start to build. So for the Mega 2560, that's the default environment for our ramps. We're currently not using that, so I'll show you how to deal with that in a moment. But first we're going to go to Source, Core, Boards.h, and inside here we're going to search on the SKR, and you can see that there's many different versions under different categories. So the one we're looking for is actually going to be way down here, and it's the SKR3. So we're going to actually copy this. Then we're going to close out of boards.h, but we're going to note what the actual processor is. In this case, I showed you it on the board, which is the STM32H743. That can be subject to change based on what Big Tree Tech decides to do if they've run out of chips. So keep that in mind. But I'm going to minimize the core and source, go to configuration.h, and I'm going to search on motherboard. So inside the configuration file, we're going to paste it over the ramps. And that's what we need to do to set our board type. Now for the serial port, it's not going to be 0. It's going to actually be -1. And then there are other things you can set in here for additional connections. For instance, for your actual display, if you're using that, there will be a connection for that. But you'll find that in the manual, as well as I'll do future tutorials on how to set that up. But I'm just trying to show you the basic firmware load for Marlin. So once that's actually configured, what we need to do is configure the default environment, which is in platformio.ini. And this works in that you have to go to the INI folder. Then you have to find your chipset, which in this case is the STM32H7. And as you can tell, that's the same nomenclature that's written on your board minus the 4-3. So we're going to find our board. Inside here you can see SKR3, and there are other boards as well. So we're going to highlight this and copy it. Once that's copied, we can minimize the INI. We can go back over to platform.io.ini, highlight the Mega 2560, and paste our chipset. So to build this, what you're going to do is you're going to click on the checkbox down here for platform.io, and this will build it inside of the .pio folder. So we're going to click on that, and you may possibly get an error the first time you build. What you need to do to deal with that is hit the checkbox a second time. And if the error doesn't go away after the second build because something's building out of order, then what you'll need to do is find the first thing that's in red in here. And that will be the issue that you'll need to correct before it's able to build. Anything after that might be a cascade of errors based on the first one. So once this is complete, what we're going to have to do is actually load the firmware on an SD card. So I'll show you that in a second. So what we'll need to do is just wait and see what happens in this folder over here. And I think it's built because of that. So we have firmware.bin. So I'm going to right click on this and I'm going to say reveal in File Explorer. So here's the actual file for our build. So I'm going to go back over to the workbench for a second. I'm going to zoom out real quick. I'm going to pick up the SD card, which is right here. I'm going to place it in here so we actually can configure it. Sorry, this is going to take a second. There we go. Place this in the computer. You may hear a beep. And the other thing I want to do is actually enable USB control for the moment because we're just running a test. When you're using direct power, you don't want to use the USB, but this is an easy example to show you how to set things up. Now that that's installed, if I plug this in, the board will power and you'll hear a beep. So if I disconnect this and pop this off and then reconnect this, it will not power until there's actual power from a power source. Now this board will run on either 12 or 24 volts. So I'm going to remove this for a second, reconnect this, and verify that it powers up real quick, which it does. So there's one last thing I want to show you that's good practice. If we go over to the actual desktop on the computer, what we can see, give me a second to get over there. So essentially what I'm trying to show you here is good practice. So let me bring this up so you can see it. So over here, what you can see is that there's a plus and a minus. So this is the plus side and the minus side. So I like to mark those. So what I'm going to do is I'm going to take out a pen and mark them real quick, noting where each one of these is so we don't hook up something backwards. So I'm going to go back over to the workbench real quick. I'm going to first take out the red Sharpie and I'm going to mark the bolts on top. This is a great way to avoid issues. Now usually for the hot ends it won't matter, but it will matter for the power supply. So I'm going to have to do this very carefully. So on the power supply, it's over here. So I'm going to mark it right here so you can see that. And then for the hot or heat bed, which acts similar to the actual hot ends, I'm going to mark it as well. So then I'm going to take out the black, and this is going to be my negative lead. So I'm going to mark that bolt, then this bolt, and this bolt. That way we have all the terminals marked so we don't accidentally put the wires in wrong. Now you can also do it for your actual fans. And if we look at these, it'll be like over here for the red here for the red, and here for the red for voltage. And then the ground will be the other side, which will be this one, and this one. So it's important to always get those right. So let's go back over to the computer for a second and actually load the firmware on the drive. Okay, now that we're on the actual downloads folder that we opened, what we're going to do is we're actually going to load it on the drive over here. Now, I've already cleaned out this drive. I want to show you real quick how to format it correctly. I'm actually not going to format it, but I want to show you that it's FAT32. So you would click Start for a quick format, but I'm going to close that for now and go back over to the drive where we have our build, right click, and I'm going to send this to our actual USB drive. Now, if you check on the drive, it's already there. If it loads correctly, it will rename this firmware.bin to firmware.cur in all capital letters. Now, cur in this case stands for current. Some people think it means cursor file, but it's actually current for the current firmware load. Now, there's a couple other things I wanted to show you real quick that I talked about earlier. For pins files, if we go back over here and I minimize this and bring up Marlin source, then I actually go to the pins folder, we can look in here to find our actual chipset that we're working with. Now you can see that it's actually STM32H, and there's two things in the file. So it's pins underscore BTT underscore SKR underscore 3.h. This may change when Marlin creates the actual space for this. It may say common and then point to a file that's similar to this that then will point to common. But as you can see in here, these are the pins files. So it's a database of pins that would be located for the board. So if we were to pick like PC1, which is an actual digital pin, this will equate to the pins over here. So as you can see, PC1 is actually the X minimum, and this is also used for the Trinamic steppers. So it's a way to do sensorless homing, which I didn't show you yet, but let me bring you over to the desk for a second and point something out. On the actual board, there's actually pins down here for the Trinamic or TMC steppers. And there's a little jumper right over here that's used to jump to set up the diag pin. That equates to being able to use the end stop pin for the digital pin on the board. So let's go back over and take a quick look around. You can see that PC1 is actually defined right here for the X minimum. And there are other pins that will equate to this board right here. So let's load the firmware now. So I'm going to go over to the actual workbench. I'm going to pop out the drive. I'm then going to place the actual SD card in here, or micro SD. We already have the jumper on. Remember to remove this if you're using a TMC stepper, or in general when you're using your actual power supply. But this is the best way to actually diagnose the board. So I'm going to plug that in. It's going to flash for a second and then beep. And that means we're actually now connected to the computer. So to check this, we're going to go over to Pronterface. And Pronterface is the software I was talking about earlier that allows us to actually communicate with G-codes down in here. I'll leave a link in the description where you can download that. But this is just to actually check to see if things are working. So what I want to do is actually connect to the board, but we don't know what the board is. So we're going to go over and we're going to search on Device Manager and open that up. And inside Device Manager, you can see that we have COM port 5. So I'm going to close this for a second and see if it's actually here. In this case it is, but if it was not, you could always highlight this, backspace, type 5, and then our speed currently is 250,000 bits per second, And that equates to the actual configuration.h down in here. So normally they tell you to use 115.200, but you can use this one as well. That's the default for Marlin. So inside of here, we're going to click connect. And as you can see, it's now connecting and the printer is now online. Now, I want to check to see if the actual end stops are currently responding in the Marlin firmware. So I'm going to type M119 and I'm going to press enter. This tells us they're all in a triggered state, which means there's a connection. And the reason that occurs currently is there's no end stop connected. So if we look at the board, you can see that all the end stops right over in here have nothing on them. When you connect your end stops, they may say triggered still depending upon your end stop type, but I'll cover that in future tutorials in order for you to understand that. And so at the moment, I need to do a shout out for all of my patrons that have been asking me to do this. And I'll leave a link in the description for people that are wanting to sign up for PayPal or they want to sign up for actual Patreon. And I'll place a thank you at the very end for the people that have signed up. So at this moment, I want to take a second to thank you all for taking the time to watch. Take care. And I'll have future tutorials for you soon.